जस्तो यहाँ a discharge of 150 लिटर per second is delivered from a canal. क्वेसन हेरौँ 150 लिटर per second चाहिँ क्यानलबाट सप्लाई गर्यो 110 फिल्डमा पुग्यो यो चाहिँ 8 घण्टासम्मको अनि सप्लाई गरेको रहेछ टोटल एरिया 2.2 हेक्टर रहेछ त्यसमा लस इन फिल्ड रनअफ 445 रहेछ र डेप्थ अफ वाटर चाहिँ 1.5 1.1 यसरी लिनियर भेरिएसन रहेछ सो एभरेज डेप्थ चाहिँ 1.5 प्लस 1.1 डिभाइड 2 भनेको 1.3 रोजन डेप्थ चाहिँ 1.5 मिटर मोइस्चर होल्डिङ क्यापासिटी 200 mm पर मिटर डेप्थ रहेछ हामीलाई इफिसियन्सी निकाल्नुपर्ने जम्मा सप्लाई गरेको 150 फिल्डमा पुग्यो 110 लस भयो सो कन्भिनियन्स इफिसियन्सी इक्वल्स टु 110 / 150 अब कति एप्लिकेसन भयो भन्दाखेरि फिल्डमा पुगेको 110 तर फिल्डमा लस छ यति मिटर क्युब 445 मिटर क्युब लस छ भनेपछि टोटल फिल्डमा पुगेको कति भन्दा 110 लिटर पर सेकेन्डले 8 घण्टा यति भनेपछि फिल्डमा पुगेको यति फिल्डमा लस भएर बाँकी रहेको यति भनेपछि यति चाहिँ 2723/3168 2723/3168 चाहिँ एप्लिकेसन इफिसियन्सी भयो फिल्डमा कति छ कति लस भएर बाँकी रह्यो लस भएर कति बाँकी रह्यो र फिल्डमा रिक्वायर्ड कति छ मोइस्चर होल्डिङ क्यापासिटी फिल्डमा चाहिँ यति छ तर मोइस्चर कति मिटर क्युब छ फिल्डमा रिक्वायर्ड भनेको चाहिँ होल्डिङ क्यापासिटी 200 mm पर मिटर छ रोजन डेप्थ 1.5 ले मल्टिप्लाई 300 mm 50% हुँदाखेरि इरिगेट गर्ने एक्सट्र्याक्सन 50% भने कति चाहिएको रहेछ रिक्वायर्ड एट द रोड जोन कति चाहिएको 50/100% 50% भनेको 0.5 इन्टु 300 इन्टु यति डेप्थ यति एरिया होलो भनेपछि यति फिल्डमा यति चाहिएको रहेछ सो एक्चुअली फिल्डमा स्टोर भनेको 2723 फिल्डमा मोइस्चर रिक्वायर्ड इन रोड जोन यति 2723 यो गरौँ भने चाहिँ यो स्टोरेज क्यापासिटी सुरु कन्भिनियन्स एप्लिकेसन भयो लस घटाएर फिल्डमा कति डेलिभर भएको यो चाहिँ फिल्डमा कति चाहिएको यो चाहिँ लस घटाएर माथि फिल्डमा कति चाहिएको त्यो गरौँ भने चाहिँ फेरि के हुँदो रहेछ स्टोरेज क्यापासिटी हाम्रो डिस्ट्रिब्युसन इफिसियन्सी स्टोरेज इफिसियन्सी डिस्ट्रिब्युसन इफिसियन्सी भने 1 - y/d * 100% भनेको 1 - डेप्थ भनेको डेप्थ होल्डिङ क्यापासिटी भनेको 200 mm 0.2 मिटर 1 - वाटर होल्डिङ क्यापासिटी डिभाइड बाई एभरेज डेप्थ 1.3 यसको दुईटाको एभरेज 1.3 मिटर डेप्थ र होल्डिङ क्यापासिटी 200 mm 0.2 1 - 0.2 डिभाइड 1.3 इन्टु 100 भनेको डिस्ट्रिब्युसन यसरी भयो यसरी भने यो 0.2 नै भयो 1.5 1.1 डिभिजन 1.3 एभरेज थियो एभरेज डेभिएसन भनेको 1.5/1.3 प्लस 30 डिभाइडेड 2 भनेको लास्टमा 0.2 नै खासमा यसरी हो The left branch canal, main canal running for very long distance, discharge यति cultural common area यति intensity of irrigation during Rabi period 80% and best period is 120 days. Again अनि right branch canal मा चाहिँ फेरि discharge यति cultural common area यति हेक्टर छ intensity 50% base period 120 days. So compare efficiency of two canal system and select the best भन्छ त्यसमा चाहिँ लेफ्ट क्यानलको जहिले ड्युटी एरिया irrigated by per meter cube discharge meter cube per second discharge ड्युटी कम्पेयर गर्ने जुनको ड्युटी बढी छ त्यसको that is the best more efficient canal भनेर गर्ने त्यसरी duty equals to total area irrigated by total discharge गऱ्यो भने per meter cube discharge ले गर्ने एरिया आउँछ यहाँ भनेको छ 20 meter cube per second discharge ले चाहिँ यति एरिया टोटल एरिया यति छ त्यसको 80% मात्रै के छ irrigated छ भनेको irrigation intensity 80% of this total area 80% of this total area was irrigated by 20 cubic 0.8 into 20,000 hectare यति एरिया to 20 भनेपछि यति आयो कम्पेयर गर्ने हामी ड्युटीसँग फेरि पनि अर्को एउटा जेनरल फर्मुला यो डेल्टा इक्वल्स टु 8.64 b डिभाइड बाइ d हो निकाल्नु पर्यो भने चाहिँ यहाँनेर b बेस पिरियड दिएको छ ड्युटी भन्दा डेल्टा तर ड्युटी निकालेर कम्पेयर गर्ने हो अर्कोको भनेको 50% अफ दिस 12,000 भनेको 6,000 हेक्टर ल्यान्ड चाहिँ कति डिस्चार्जले 8 भनेपछि पर मिटर क्युब 6,000 by 8 whichever greater that is best efficient canal. Okay, finished. Now next one is water course commands an irrigated area of 1,000 hectare intensity of irrigation 70% that is area irrigated by total area during 15 days and depth of water required by the crop during this period that is total base period is 0.5 meter 500 mm useful rainfall is 120 mm find diesel duty of irrigation water on field during transplantation duty at the head of water course assuming 20% loss discharge required in water course total cultivable common area is 1,000 hectare irrigation intensity 70% that is 70% of this 700 hectare is irrigated intensity of irrigation 70% area irrigated is 70% 700 hectare now total depth 500 mm loss 20% useful rainfall 120 mm 15 days depth of water supplied by irrigation is total depth during irrigation 500 minus 120 equals to रेनफल 500 जम्मा इरिगेसन गर्नुपर्ने 120 चाहिँ टोटल जम्मा रिक्वायर्ड 500 120 mm चाहिँ रेनफल भयो भनेपछि कति इरिगेट गर्नुपर्यो डेप्थ डेल्टा इक्वल्स टु 0.38 मिटर बेस पिरियड इक्वल्स टु हाउ मेनी डेज यहाँ दिएको छ 15 दिन डेजमै हुन्छ 8.64 बी बाई डेल भनेको एरिया ड्युटी आयो नाउ ड्युटी आयो again at the head of the water course equals to 20% loss हेडमा ड्युटी अफ इरिगेसन ड्युटी अफ इरिगेसन इक्वल्स टु यति 20% लस गऱ्यो भने minus 20% and discharge required in the water course discharge भनेको चाहिँ meter cube per second volume by time that is discharge equals to area by duty q equals to area by duty delta in meter b in days depth meter b in days duty equals to area of land irrigated per meter cube per second discharge so area meter cube per second per unit discharge okay this is area by duty equals to discharge equals to area by duty unit of delta is meter unit of base period equals to days and unit of this duty is total area per meter cube per second discharge means meter square per meter cube per second area is generally kept in hectare so hectare per meter cube per second normally unit consumptive use or evapotranspiration consumptive use or evapotranspiration before any consideration or evaporation we should have an idea of what the terms means transpiration means what process in which water entering the plant root is used in building of plant tissue this water passes into the atmosphere in the form of vapor from leaves of plant water is finally passes to the atmosphere in the form of vapor from leaf of plant. Transpiration is the process in which water is evaporated to the atmosphere in the form of vapor, finally from the surface of leaves. Evaporation is water that passes to the atmosphere in the form of vapor from the water surfaces. That is from soil surface evaporation, from plant leaf transpiration. These two are in combining evaporation, transpiration, transpiration Evapotranspiration means evaporation plus transpiration. Evaporation occurs from open water surface, soil, vegetation surface, and transpiration occurs from the surface of plant leaves only. This is this is the factor affecting consumptive use or use means water use. Evapotranspiration losses is use. So total irrigation required, that is consumptive irrigation requirement CIR मा जहिले पनि टोटल युज कति हुनुपर्ने माइनस रेनफल, इफेक्टिभ रेनफल माइनस गरिन्छ भनेको रेनफल चाहिँ इन्फ्लो भयो, कति चाहिएको भनेको टोटल चाहिएकोमा रेनफल घटाउने, कन्जम्प्टिभ युजमा रेनफल घटाउने भनेको CIR equals to consumptive use or evapotranspiration loss minus rainfall, effective rainfall CU minus RE. CIR equals to CU minus RE. So this CU consumptive use depends on the weather parameter, crop factor, environmental conditions. Potential evapotranspiration, actual evapotranspiration. Read yourself. Now, important point. PET, if water supply is less than a potential, soil starts drying. Hence, when PET is greater than water supply, actual evapotranspiration divided by potential evapotranspiration is less than 1. For clay soil, actual and potential evapotranspiration is equal, and when soil moisture reaches ultimate wilting point, then AET equals to 0. If supply of water to the plant is not limited, soil moisture will be at fill capacity, and actual evapotranspiration equals to potential evapotranspiration. Actual evapotranspiration equals to potential evapotranspiration. That is, for clay soil, water supply to the plant is not limited. That is, soil moisture will be at fill capacity. Actual evapotranspiration equals to potential evapotranspiration. So AET by PET equals to 1 for clay soil, because soil moisture will be at fill capacity. Soil moisture will be at fill capacity case means AET equals to PET equals to, so ratio equals to 1. When PET is water supply, then AET by PET is less than 1. Methods of determine the consumptive use of water. Two categories: direct measurement and use of empirical formula for the determination of consumptive use of water. Another category of direct measurement, we have lessimeter method, influent free study, soil moisture study and plots. On consumptive use or evaporatory transpiration loss or PET, CU, evapotranspiration loss. Is empirical method. This is direct measurement method. This is empirical method. Okay. Lessimeter method, direct method. Blenny-Riddle method. Hargreaves pan evaporation. modified Penman. These are the empirical methods. In direct method, lessimeter method. Lessimeters are cylindrical containers which are open at one end and are set into the ground with their rim flush with the ground surface, have a pervious button. A part of water applied to the plant is allowed to drain through the pervious bottom, which is collected in a pan kept below it, and this method is carried out in an area which is isolated from the rest of the field. The consumed use of water is obtained by calculating difference between water applied and the water remaining collected in the pan. That is, consumptive use of water is difference between water applied and water collected in the pan. That is consumptive use. Decimeter are cylinders open at once. These are placed at ground surface and this has permeous button ground surface. A part of water is applied to the plant and decimeter is placed below the plant, allowed to drain through the pervious bottom of the decimeter, which is collected in a can kept below it. Decimeter has a pervious button. It is placed below the plant, near the plant, and the water is collected. Total water supplied minus collected equals to consumptive use in direct method. This is Blaney-Criddle method of indirect method estimates seasonal use. Criddle developed similar method. In this method, monthly consumptive use equals to Kp by 41.80 plus 32 K equals to curve factor, T equals to mean monthly temperature, P equals to monthly percentage of annual day time hour. That is, T equals to P by 41.80 plus 2 T, Cu equals to K into F. F equals to P by 40, 1.80 plus 32, K into F, where P equals to monthly percentage of annual day. Monthly percentage of annual day. T is mean monthly temperature. K is crop factor. Determine the exponent for each crop. So this is the K into F or summation, or this is by Blaney-Criddle method. Hargreaves method is next method. Penman method. This is Penman evapotranspiration, consumptive use. Evapotranspiration potential, evapotranspiration acceleration is determined by Penman's equation by this method too. Now, table below gives the detail for a certain crop. Monthly, month, November, December, January, February, temperature is given and monthly percentage of days is 7.19%, 7.15, 730, 7.03. We are going to use this Blaney-Criddle methods of indirect Cu measurement. Useful rainfall. Now use Blaney-Criddle equation to determine the consumptive use, CIR, FIR, application efficiency 70%, latitude 30°, solution F equals to P by 41.80 plus 32. This is Blaney-Criddle method. CU equals to K into F sum. So K is given, F is P by 40, 1.80 T plus 32. T is time percentage. P is average. T is monthly temperature, average monthly temperature. P is monthly percentage of day. So CU equals summation of K into F. K is 0.75 always. Summation F equals to this formula applied. P equals to this 7.19, T equals to 19, then F equals to P by 40, 1.80 plus this total sum 42.46 into K equals to Cu rainfall equals to effective rainfall equals to given useful rainfall is 1.8 plus 0.1.2 plus 0.8 equals to 2 centimeter. So Ci equals Cu minus Re, Nir equals to Ci R plus losses. No water is for deep percolation. Loss is not given. This CIR by NIR. FIR equals to NIR. NAGIR equals NIR by NC. Normal formula अर्ने भयो यसमा यो एकचोटि आफै हेर do yourself. The following cropping pattern is evolved under a reservoir crop pattern. Different crop for different season. Best period is different. Outlet factor, that is duty intensity of irrigation. Now intensity percentage, crop ratio, given. Gross command area 80% culturable, 80% of this culturable, and intensity is irrigated by total area. Intensity of irrigation II equals to area irrigated by total area, that is of CCA, culturable command area. So extra water 20%, time factor 13 by 20, 3.0 by convenience loss 20%, convenience efficiency equals to 80%. Now determine capacity factor for main canal. Design discharge at the head of the main canal. Total area, this CCA equals to 80% of this. Crop ratio equals to Rabi to Kharif or Kharif to Rabi. Crop ratio. Okay. Sugarcane area for sugarcane equals to